We're going to be getting into bridge design right now. And when you start your bridge design software by West Point, you're going to see it gives you some options. The first bunch of options we're going to keep the same. So click Next. Over here, you can click Next. It's telling us a couple of things now that we can choose. And the cost of our bridge so far is right here. It's $67,600. And the cost comes from excavation, putting these concrete posts in the side to support our bridge. And that's really all we have right now that is causing those costs to go up. We're going to leave the deck elevation exactly the same, so we're all working on the same bridge. We're going to leave the standard abutment. We're not going to do an arch bridge. And these two things, actually just this one right here, it's up to you. You can choose between a pier or no pier. Notice the cost difference with a pier. Here's our cost down here again. When I put a pier in, it jumps up $40,000. Now you need to figure out through trial and error whether putting a pier in the middle is worth that $40,000. Does it make the overall cost cheaper because you can use cheaper and less material? Or is the cost not worth it because there's so much cost on that one item? It's up to you. You'll have to figure that out. Once you have chosen, click Next. I should mention, don't put cable anchors in because we don't have a suspension bridge. A cable anchor would be a big chunk of concrete here that the cables on a suspension bridge would attach to. But you're just adding expense with nothing. You won't get anything out of that. So click Next. We're going to leave it on a standard truck. That means 225 newtons are going to be applied to this bridge to see if it will hold that. And you're going to have to choose here. Do you want medium strength or high strength concrete? Don't choose the 480 newton load because that's just going to almost double, actually more than double your load, and you won't need to do that. So click Next. Right now you could start with just nothing and work your way from here. I'm going to allow you to choose one of these templates if you would like to. You don't have to. But if you'd like to, you can choose one of these, click Next, and all this is going to do is give you a template, something to base it on. The 3 designs that are there, those are really well-known architects who have worked this out and have a really good idea of a design that works, and then you would tweak it from there. You're going to type in your name here for Designed By, click Next, and Finish. Okay? At this point, you have to put these little circles in, these little connectors. Whoops, I accidentally put one in the wrong spot. We'll fix that in a second. You go through here and you can follow your template or you can deviate from the template if you'd like to. And you're just going to make sure that all of these connecting points are there. They're sort of like hinges, but if you don't have those, it won't work. I'm going to grab my little arrow here so I can move this one over and go back to this button right up here. And the reason I'm using this button is because this is going to allow me to put in my material all the way across. Picture this as like a big beam that's going to go across. I can also grab these and put my cross pieces in. I'll try to do this quickly for you, but you still have a couple of choices that you can make. In fact, there are 3 variables you're going to be deciding between as you're making your bridge. The first variable is the material of these bars that I'm making. So you can use quenched steel, you can use an alloy, and here are your choices, or you can use carbon steel. Okay? Now there's differences between each of these, which are described in that beginning tutorial, but the high strength alloy steel costs more. So you'll see if you choose all of the things and make some changes, you're going to see what happens. So if I grab this, I pull all the way to the bottom, all of my pieces are now selected. This data over here, this data chart is where you're really going to make all of your changes and where you're going to get your information because it's giving you very specific data where you will know when each piece is going to break. And that's really valuable. So if I change this, right, from carbon steel, nope, my cost is $328,000. I'm rounding a little bit. And I change that to high-strength alloy steel, it goes to $400,000. So it's significantly more expensive. If I go to quenched and tempered steel, even more. It's even more expensive. And so if you can get away with a carbon steel, it's cheaper, but it's also not as strong. And so that's what you're giving up. I can go with a hollow bar, which is, a solid bar right now at $328,000, to a hollow tube, $154,000. And so less than half the cost, but I think you're going to find these are far less strong. The last variable you can choose is how thick or big those tubes are or bars. Notice I'm almost at $1 million now. It's way too expensive. No one would actually build this bridge in real life because it just costs too much. So we have to dial all of that in. And here's how you test your bridge. You click on this teal button. Nope, my bridge did not make it. The truck will show up, but unfortunately the truck can't pass because my bridge fell down. I look over at my data. Most of my members actually did okay. These did not. And so those were either too thin, the wrong material, or need to be a solid bar. And so I can make a choice here. Which one of these things am I going to change? Let's make it a little thicker and see what happens. Try it again. And that's pretty much what you're going to do. Notice I didn't wait for the truck that time. I just changed it, and it worked. Now, the problem right here is these worked, but they're actually too strong now. And I know that sounds like, well, it can't be too strong. It's too strong because I can get away with a lesser material, and it will still work. And so I'm spending too much money. So the goal is to make the cheapest bridge that will hold the truck. And so I can use these buttons to make it just slightly thinner. These all failed as well, so I need to do something with those. So I'm going to make these slightly thicker, and we try it again. And this is pretty much how you'll do it. You'll go back and forth, and if you look here, this is at 104. It will break as soon as you get to 1. If you are at 0.99, it will not break. If it's at 1.00, it will break. And so that's how you're going to look at these to figure out which is the best design. This one has 0.01 and 0.26. It's being pulled 0.26 and it's being smushed 0.01. It's way too strong. It's costing me more money. So I can get rid of that, make it smaller, do something, and it will still pass. See, it's easily passing, and I changed the material a lot. So make some decisions, make the cheapest bridge you possibly can that works. And so the goal is to get that truck all the way over your bridge.